Assalamualaikum warahmatullahi wabarakatuh and a good day to Sir Abdullah Sani. Today, Michael, Jazmina, Zulaikha, Feeza and I, Alysha, will be presenting our Data Communications and Network project. First of all, we were given a few choices on the theme application layer protocol in action, and the topic we have chosen is Domain Name System, DNS. Let's dive into our project. So the application layer is the topmost layer in the layered model of the OSI and TCP/IP model. The application provides services such as email, network resources, and transferring files. Examples of application layer are like the HTTP and DNS protocol. So the main purpose of this study is to ensure that each of us has acquired enough knowledge on our chosen topic. Our main objective is to learn and understand the way DNS protocol works in the application layer. For the task distribution, each group members were asked to do some research on the DNS protocol. And after that, we have gathered all the information needed, and then the tasks were divided into 5 parts and were distributed among us. So first, Jazmina, she will be finding out on the information of DNS in the application layer, and she will be focusing on the literature part, which is summarizing the things we have learned based on the research we have done on DNS. Next, Amira Feeza will be searching on what application or software implements the protocol and how. So she will be focusing on the methodology, which explains on how we implement the protocol and explore the application. So next, me, Alysha, will be searching on how the application works and how to apply the concept in our test. And I will be focusing on the result, which is writing about the result of the test we have done. Next, Michael, he will be focusing on identifying the mistakes and ways to solve for a successful test. And he will be focusing on the discussion part, which explains on the results and analysis. Then Zulaikha, she will be finding out on threats to DNS protocol and how to monitor DNS. And she will be focusing on the conclusion part, which she will be concluding what we have learned throughout the project. So I would like to pass to Jazmina for continuing the presentation. Thank you.
Okay, thank you, Alysha. So I will be explaining about the literature and our findings. So what is DNS? So it is undeniable that the domain name system is taken for granted because it's not something that we are able to see when surfing the internet. And little did we know that we actually use it every day to get our tasks done. So domain name system locates computer and other resources on IP network through a hierarchy, which later makes the translated domain name unique and easy to remember. Domain names are characterized by dots and are more human-friendly. For example, www.twitter.com. So the domain name system is composed of namespace, name server, and resolver. When you are connected to the internet, the DNS server you use will automatically be set up by your network provider. DNS server will link domain names to their IP addresses that are associated with them. Your computer connects your current DNS server when a domain name is typed into your browser and asks for the IP address domain name that is associated with. Your computer will connect to the IP address and direct you to the right web page or content that is requested by the user or you yourself. Domain names are organized into a hierarchy. So just like a family that has hierarchy, domain names is followed by top level domain, which include the domains like .com, .org, .net, and so on. And the siblings of TLDS includes country code like UK.au and so on. DNS work with clients using mechanism called resolver and ask server. This process is called query. There are three types of DNS query, which are recursive query, iterative query, and non-recursive query. And there are a few open source application or free software that can be used to implement protocol. That would be ENSP, Minimat Network Simulator, or Cloudflare. So let's move on to the methodology. So I'll pass it to Amira Feeza.
Thank you, Jazmina. Now I'll explain about our methodology. So DNS can be used or traced by a few different applications like Command Prompt, Wireshark, and ENSP. Command Prompt is available in most Windows operating system. On the other hand, Wireshark and ENSP have to be downloaded from a website. After completed downloading and installing the Wireshark, we can proceed to capturing DNS in Wireshark using Command Prompt. First, we start a Wireshark capture, then we open command prompt and run it as administrator. After we open the command prompt, type ipconfig or flush DNS and press enter to clear the DNS cache. To display the DNS cache, type ipconfig or display DNS and we press enter. After it has been displayed, observe the results and notice the only records currently displayed come from the host file. Next, type nslookup and the name of the website and press enter to interpret the output from nslookup that shows information for the website entered, such as server, address, name, and addresses. After that, we can close the command prompt and stop the Wireshark capture. Then we observe the packets captured in Wireshark and locate the query and response message. Another method that we use to test the DNS server is by creating a scenario in ENSP. For this project, we set up a topology of two routers and did a static routing to connect both routers. Next, we created IP addresses for each router and the loopback address. Moving on, for the first router, we configured the Gigabyte Ethernet 0/0/0 interface IP address and a subnet mask. By default, the port is shut down, so we command undo shutdown to open the port. The second configuration interface for the first router would be the loopback 0 configuration with the IP address and the subnet mask. Likewise, we configured the second router the same way except for the IP address. After all configurations were settled, we run the test to capture the DNS packets. So as usual, we captured data by opening the Wireshark application. For the first router, we ping the IP address of the second router and vice versa. Next, we ping the loopback address and the domain. Finally, we stop capturing in Wireshark and observe the captured packets. Now, I'll pass to Alysha to explain about the result.
Okay, so for the result part, we have done 3 tests. The first 2 tests were run on command prompt and captured packets on Wireshark. So the first 2 tests were a success for us since we managed to get what we wanted, which is locating the DNS protocol on the Wireshark. So the first test, we receive it on the IPv6, which is the Internet Protocol version 6 frame. So, and then for the second one, we receive it through the IPv4. So, however, for the ENSP test, it was a failure for us. It will be discussed more on the discussion part, which will be explained by Michael. So I would like to invite him to continue the presentation.
So continuing from Alysha, I will be discussing about the analysis of the result. So based on the first one, we had a successful DNS capture. We successfully captured the packets from the Wi-Fi adapter. So looking back at it, for this particular capture, we captured in IPv6, but there's also an IPv4 version. But So far, my laptop can only do IPv6. Then we choose the packet that we have pinged from the command prompt. After after picking the packet, we see the 3 frames in the Wireshark. That we look at the middle pane, which has all the information that is captured from the DNS packet. Even the last and lower frame, there is also the data that it is translated in the middle pane. So in the middle pane, we'll be looking at the data link layer first, which is the Ethernet 2. For this layer, we should be able to see the source and destination address of this layer. The source address should be the MAC address of the host, and the destination address is either the local DNS server's MAC address or the host current gateway address. As seen in the picture above, the results in the Wireshark corresponds with the address of the host. We can also look in the command prompt uh, by typing in the command ipconfig/all or arp/a. Next, we move on to the upper layer, which is the network layer. This layer for this case, I mean, the IP it will be IPv6. From this packet, we can see that the source address is also the IP address of the host. The destination address is, on the other hand, is the IP address of the DNS server of the host. Next, we move up to the next upper layer, which is the transport layer protocol. In this case, we use the UDP protocol because DNS, even though DNS supports both UDP and TCP, its default protocol will be UDP because of the faster speed. It will only use TCP when the packet is too big or the exact amount is after 512 MB. So as we can see in the source port, it uses a dynamic or private port for this DNS query. This means that the port selected is above 49,000 and in between and less than 65,000. There are other different types of ports, but we are not going to be discussing about that. Following that will be the packet itself, which contains all the DNS information. We are able to see the details of the DNS. When we see the flags that are in this packet, we can see that it has a recursion desire flag, which means the query to the server, it queries the server recursively. As explained by Jazmina previously, the server will, if it cannot find the cache, the DNS cache, it will go back to the root domain and it will search from there. If it's not available on the current DNS, it will ask on its behalf to another DNS server. The DNS server is an iterative server. Then it will follow the last hierarchy of the domain names until we get the domain nwikiversity.org, which is the example for this case. Lastly, we open the queries tab and we can confirm the details that was previously stated uh, by the type of the record and the domain name. For the failed attempt in ENSP, we didn't get we didn't manage to capture any DNS packets because ENSP the doesn't support the configuration as much as a real and certified DNS query. So lastly, I would like to pass it to Zulaikha to conclude the report.
Okay, thank you, Michael. So it stated that IPv6 is the new version of the IP protocol that provides important new capabilities, including a larger address space, more flexible subnetting, simplified address assignment, and improved security. As IPv6 adoption grows, DNS is becoming more important as a mechanism to help users using both IPv4 and IPv6 hosts reach the most appropriate IP address. If you operate your own DNS server, switching to the IPv6 DNS requires configuration on your server and creating two sets of records to ensure you can continue to support traffic from IPv4 hosts. The two protocols are not interoperable, so IPv4 hosts cannot communicate with IPv6 hosts at the protocol level. However, mechanisms have been developed to integrate older and newer hosts and allow communication from IPv4 to IPv6 and vice versa. So for more information, there are various ways to improve the DNS server security due to the cyber threats to it. So firstly is by mitigate DDoS attacks with multi-layered protection. So to defend against all types of DNS based equipped with DDoS, use a solution that comes with multiple layers of DDoS protection. So DNS nodes should be equipped with DDoS mitigation that happens locally. If an attack is supersized, malicious traffic should automatically reroute to a mitigation network, a completely separate purpose-built infrastructure. Thus, limits any potential damage to the target name server IPs. With the impact isolated, the 24/7 security operations team is free to be more aggressive in their countermeasure. Next is by isolating the name server through segmentation. We need to choose a DNS provider that organizes the DNS network into segments, each with a name server announcement shared by only a small group of customers. With fewer customers sharing host name and IP addresses, the user will face drastically lower odds of feeling a ripple effect. This approach enables individual name server announcement to move from the DNS network to the DDoS mitigation network without significantly delaying query resolutions. So last but not least is by deploying the DNS security extension DNSEC. So in more basic terms, DNSSEC secures the DNS process by protecting against cache poisoning, farming attacks, and other serious threats. So as a conclusion, DNS servers play essential roles in today's internet and in many private networks around the world. So it is beneficial for anyone using a computer or network device to know more details about this DNS server. Few services affect so many systems and users of those systems as much as DNS, which is involved visually every time someone accesses a network. To sum it up, we are yet to resolve the non-successful test. Nonetheless, from the findings of this report, we got to learn and understand more on how the DNS servers work in the application layer. Not only that, we discovered application and software that implement this protocol. From this project also, we gained some knowledge about the method on how the protocol is implemented and explores the application to get a better picture of the concept. That's all. Thank you.
So from that, we conclude that this report, we would like to thank Sir Abdul Lahisani for all that he has taught us and for giving us the opportunity to do this report. On behalf of the other members, I would like to say thank you and sorry for any mistakes that we have done throughout the presentation. That is all from us. Thank you.